Recording.
Mhm.
Hi, Shelly.
Are you on Slack, Francisco?
Yeah.
There's Chris.
So Zoom records on the cloud, right? It doesn't record on my machine, is it?
Yeah.
Hello.
Hi.
Hello.
Hello, everybody.
Great to see people.
Hi, everyone.
Hello, hi.
Hi.
Hi, everyone. I'm going to be repeating this.
I don't think we should email again the Zoom link. Do you think?
No, I think that the link on that document on Google Docs is fine if it's
Yeah.
updated.
Yeah.
Hi.
Hi, Chris.
Hello.
Where are you, Chris? There you are. People are coming in. Yeah, lots of people here. Good to see.
Maybe if you guys co-host each other, then you'll always be at the top as speakers.
Can we co-host? Can we have more than one host?
Yeah,
You can
make
co-host Chris and Thor.
Yeah, and
Oh,
then you
okay.
kill off everyone else.
Co-host. Co-host. Okay. There you go.
So I guess we'll wait 5 more minutes or something.
Mm-hmm.
I think the chat has been quite busy and nice on Slack.
Oh, just received an email from Arden Dowry, who didn't get a confirmation link.
No, there were some people who didn't provide the right email address. We got faulty. So just, can you send her the
Yeah,
resource docs?
yeah.
So Chris and Francisco, you're ready with your stuff? I'm gonna give a little talk first. Francisco, you can turn the audio off for and everyone except us three.
Okay, just sent an email to someone else. Um,
I was just saying, can you hear me?
yeah, I'll turn everything off.
So we don't have to listen to some dog barking or a train.
3D printers.
Oh, I tried to mute all. Mute all. No. Okay. Unmute. Oh, I can. Oh, okay. Unmute.
I can unmute myself. I can unmute Chris.
Chris. So everyone is muted? No. Oh, I see. Something else. Mute participants upon entry. No. Enable. No. Right. That's it.
So I hope people are finding the.
Hey, Kisha.
I hope people are finding this Zoom link.
Maybe shall we check Slack just to see if there's any problems with fax?
I am on Slack. There's
Canon
no
Slack.
problem there, but
Work on Vim. Yeah, we'll have Vim. Can't toggle off the speaker icon. Sorry, Elias. You can't indeed. Yeah. Okay, so there's a lot of questions that we need to go through. The first, so there's also a lot of people trying to access the website on www.sama.codes, and it's not correct. It's just sama.codes. So we've sent an email to correct that previously. Anyway, we've just started. Shall we make an official start, Tar?
let's give it 1 or 2 more minutes because we had problems with the URL to the Zoom. There might be people having to figure out now in a bit of a panic where, but it's on the Slack channel and it's on the workshop resources document. So I believe everyone will find it.
All right.
Francisco,
Yes.
did you just turn off the video of everyone?
Did I?
No. No?
No, I see Chris.
Okay.
I see many people.
Mm.
I see Shelly in the green pasture. That's nice. Right. 67 participants.
Yeah, people are popping in. Let's give it 2 more minutes and start by giving a little introduction.
Oh, there's an interesting functionality, which is the pin video. We might want to pin ourselves.
Yeah, well, it's you who can choose which pin to video, right?
Right. The perks of the host.
Can you mute the people who have come in, Francisco? There are new people who have come in who are not muted.
Mm.
I mean, all at once. Okay. I think we could just start, right? What do you think, Chris?
Yeah, I
Chris.
think so.
Yeah. So I'll give a little welcome before I hand over to Francisco and Chris. So my name is Thor Magnusson, and I'm part of the Sussex team who has been developing the SAMA software. And we're developing this software as part of a project called Mimic, which is an Arts and Humanities Council funded research project in the UK, where we work with Durham University and Goldsmiths University on making machine learning technologies available to creative coders. And the focus is specifically on JavaScript and web-based programming. So what we focused on was to create a live coding language for machine learning. But when we started thinking, what kind of language should we create to interact with machine learning, we kind of thought that it didn't make sense to design one specific language that everyone has to use, but rather create a framework for everyone to create their own languages for machine learning. And the fact is that as most of you are musicians, you know that the tools that we use often influence the way that we think and the music that we make. So it's important that we can create our own languages, our own mini languages or so on for live coding. This will strengthen the diversity of the tools and the music that we're making. So so I'm Thor Magnusson. I'm a professor in music at Sussex, and with me are Francisco Bernardo, who's a postdoc with us, and Chris Kiefer, who is a lecturer in music technology at Sussex. And I welcome all of you to this workshop. We're really delighted to be able to run this workshop online and to have all these people from all over the world joining us. This is basically because of COVID. We were going to run a physical workshop in our lab, in the Sussex Humanities Lab. But because of the virus, we turned the workshop online. And that's actually quite interesting. Because now, instead of having 15 to 20 people in a room in Brighton, we have 200 people all over the world with us. And that's pretty amazing. It's wonderful. We have people from Europe, North America, South America, Middle East, Asia, all over Asia. So it's really fantastic, and this is very exciting for us. And of course, doing a workshop on Zoom is new for many of us. At least it's new for us running the workshop. We have been doing many workshops in physical spaces, but doing one in Zoom is new. So how is this going to work? We thought we would use what is often called in pedagogical kind of literature, flipped learning. So you do most of the studies at home by doing your reading and experiments and following tutorials and so on. And then we come together in a seminar like this to discuss things to talk and to have a more kind of critical reflection over what we've been doing at home. This is something that we do in teaching in universities as well, but it kind of lends itself very well when we're doing this kind of, when we're all sitting at home, most of us, and we have the time to study beforehand. So I hope you've all been able to log on to Slack, because this is where we're going to be running the conversation over the coming days. It's also where we will be running the conversation during this session here. So if you want to ask Francisco and Chris and myself some questions, you will do it through Slack and not through Zoom. I can see some of you are not muted. If you could all mute your microphone, that would be good.
I think it should be muted when they go in there.
But it should be, yeah, but I can hear some noises. Someone called Steph. Yeah, good. There is the workshop resources document that's on Google Doc. I think you have that. It's good to bookmark that during this week. And for those of you who are willing to take part in the user study, I've sent you an email specifically with a link to a page where you just have to tick some boxes and say that you agree to the user study. It'll take you a minute. Finally, before I hand over to Francisco, I should say that SEMA is a work in progress. It's bleeding edge technology. It's early days. We've just launched it, but it really works. We've been using it in performances before. We've been doing research with it. And of course, we do things our way. And now suddenly when we have lots of people using it, we find that there are things that need to be fixed. So we have the bugs channel on Slack, and we also have issues reporting mechanism through GitHub. Of course, there's a lot of further work needed in this software, and that's what we are going to be doing in the coming months. So SEMA allows you to create your own language for machine learning. It's a platform for exploring how machine learning can work in creative coding. And we're really excited to see what you come up with, how we together explore what machine learning can do as kind of a tool in the tool chain of music making. We don't have the answers for all of that. We are just creating the kind of toolbox for people to start to use those tools for something exciting. So this is really just as exciting for us as it is for anyone else interested in machine learning and live coding. Oh, and finally, I should say also that with us here today, we have Shelley Knotts, who is part of the Mimic project, and she's also running the Network Music Festival. And this festival will be running from the 15th of July. And there are some slots available for some network music in one of the evenings there. So we have allocated a few slots there in that festival for people in this workshop. So if you come up with some nice music or some nice experiments here using SEMA, it would be really great to see it performed in this Network Music Festival in 2 weeks' time. So you would have time to develop your own music and languages and systems before that. But what I'm going to do now, thanks for being so patient, I'm going to hand over to Francisco, who's going to kind of introduce the tutorials that he developed and the videos that he created. And after that, we will move over to Chris Kiefer, who will do the same. But then we will maybe open the up for some questions and comments and so on. Some improvisation, maybe. But Francisco, yeah, do you want to take over?
Sure. Thanks, Lar. Hi, everyone. My name is Francisco Bernard. So I'm a postdoc in SEMA. I've been working on the development of SEMA. So right now we have a prototype that's living on the web. For many months, that wasn't the case. It was running as a Node application on your computer. We did some workshops in that mode, but the intention was always to move this application to the web, to the cloud, so that we could scale up this application or this live coding environment as much as possible, and to relieve the user from all those pesky installation issues that usually come with experimental software. So that said, SEMA is a live coding environment, as we've been mentioning. We're bringing in machine learning and we're bringing in language design. And those are two unique features that, and of course, all of this in an integrated environment in the web browser. So mostly those are the unique features that SEMA can offer. So I'm going to, so these, we've been writing up some tutorials. We have an integrated and interactive tutorial in SEMA, which you might have experienced or worked with. So I'm just going to share my screen and have a quick walkthrough to SEMA. Okay, so share. So can you see my my full screen, my screen share?
Yeah, it's good.
So right now we're looking at one of the main areas of SEMA. So this is the playground area. So we think of SEMA as itself a whole playground. Like there are many code playgrounds on the web, like Pastebin, you know, all those JS Fiddle. So those are like coding playgrounds, and we decided to do something alike. So this is our own live coding playground on the web, and this is the playground area. There's a tutorial area which you might switch to, and where you can go through all the tutorials. So the first video, the getting started with SEMA video, what it does was just like a basic introduction, like quick dive in to SEMA. So if we start from the beginning, if you do like a full walkthrough, we have a landing page, which you can log in as a guest. I think there were some people that found some problems on the logins, mostly because they tried to log in with their own account and there were some problems. I think I fixed this earlier in the morning, but let's see. So you go to the playground. The first thing that you have to do is to turn the sound on. So that's where you do it. Yes, there's an issue also with the icon that doesn't load at the first time, but then it becomes red. So, oops. Right, so I just placed my cursor on the live coding editor, which this is this area. And to evaluate the code is a combination of keys, which is the command enter, which I just pressed. So I see that there were also a few issues, mainly across the different platforms and Linux and Windows. I guess Windows users are finding more problems. We didn't have any Windows machine to test, unfortunately, but we will try to fix that as soon as possible. Right, so the playground has a lot of different widgets. This is the live coding editor. This is an audio analyzer. These are debugging tools that will assist on the language design process, and you can create them as you go. And you can create a grammar window, you can create a model window, and some other debugging widgets, as I said, like what's the code that's generated. So stepping out of the playground into the tutorial, we have a first set of basics tutorials that you can see right here. And they basically do this introduction that I'm doing, like they present the basics of the interface, they state what SEMA is, what it's like, what it does, how the tutorial is structured, what each part covers. So this is kind of a lightweight introduction and a progressive learning experience in which the idea is to start at the beginning and go through all of them so that you can have this gradual learning experience, because there are dependencies. So the idea is that first you know what are the basics of the playground, like what are the links to the community, to the documentation that are there. How do you interact with the widgets, how you can change them, resize them. So the tutorial is also interactive. So everything that happens here, everything that happens in the playground, it's replicated, the functionality is replicated in the playground. So there are also commands. There are commands that are common to both areas, to the playground and the tutorial, like the audio and the login. There are commands that are only specific to the playground, which are the ones who reside on this side, and that typically they help to populate and control the dashboard. There's also specific commands to each window, such as the evaluate or the stop sound, which is the control enter or the control period. There's also a short introduction to the specificities of each editor, like what are the specific commands, like not, for instance, the grammar window doesn't have like any explicit command. It does continuous evaluation, like for each keystroke, each change, it's generating a new parser. And then a little introduction to the debugging widgets with a short exercise that shows briefly, doesn't go into much detail because we'll be covering that on part 4 on how to use the debugging tools with the language design workflow. Right, so this covers pretty much this basics walkthrough. And now I'm going to pass the word to Chris about the language design workflow, the live coding with the language, the default language.
Oh, hi. Francisco, do you want to unshare your screen then?
Yeah. I'm just trying to, okay.
Okay, great.
Can you, okay.
So, well, what I wanted to say today is probably a bit more kind of reactive, thinking about people's questions, but maybe just to think about the kind of flow of work and material that we're going to cover over the next few days. So we've seen Francisco's introduction to the system as a whole, and then there's 4 tutorial videos up on the YouTube channel which cover the first 4 tutorials about the default language. And then, so what we're really trying to do today is just get familiar with the basics of using the default language. And then tomorrow we'll start to move into some more advanced use of the default language and kind of start to shift over into looking at how we involve machine learning in live coding, and we'll use our first kind of very simple machine learning model, and that will set us up for Wednesday when we start to think kind of more deeply about machine learning. So today is all about just getting familiar with things as a foundation for the next day, which is a foundation for the next. And so the tutorials are up there about the default language. The default language is, as it says in the tutorial, a kind of what you might call unremarkable language, because there's the potential to have so many languages in the system, and we don't really want to define it by one SEMA language. So the function of this language is to just kind of expose all the stuff that you can do with the audio engine. And so it kind of lets you use the audio engine with kind of full functionality. And it's got a few kind of tricks in there that are useful for live coding performance as well. But it'd be much better if you went and designed your own language at the end of this week, once we've been through that. But this default language is just a kind of means to an end. So it's the utility that lets us hook up machine learning with the audio engine and get to know the stuff about machine learning. So kind of beyond that, I think maybe the best thing to do is to take questions. So if you've been through the tutorials and you got some questions, maybe we can try and answer those now, and we can kind of think of this as a kind of reflective workshop rather than top down.
Well,
But
in
how
that
do we do
case, we could, people could just ask questions maybe here.
Yeah, we could do that.
Mm.
Or you could put them on Slack as well, either way.
Somebody has a very clever question now.
Okay.
Acoustic mirror. I'm just watching I'm reading the comments here.
Okay.
Do you need to unmute people, Francisco, or?
Oh, shall we do that? Okay. So who should I unmute? Acoustic mirror?
Acoustic mirror.
Okay.
Hello. Hi, acoustic mirror. You can be acoustic now.
He's still
No, it's
unmuted. Now
Right.
he's
okay.
now he's.
No.
Right
I
there?
think we can hear him. Yeah.
Okay, good. Just a silly question. I just went through the first basic video tutorials, which were great, very clear. Now, samples. Is there some basic, easy way to add our own samples from an online share or something to the SEMA system, the playground?
I can answer that.
Or is that complicated? Right.
At the moment, there is a way, but it's a little bit complicated. So what you couldn't do that with the online version, but if you feel comfortable enough to download the source and run it from your computer, then you can add your own samples quite easily.
Okay.
So unfortunately, we can't do that with the SEMA.code site at the moment. But
Do you want to explain why that is, Chris? It's because of JavaScript security issues, isn't it?
Right.
It's kind of just a feature we haven't got through to yet.
Hmm.
Right.
So it's a future implementation.
Sense.
So basically, we would need to have a file upload subsystem and all that it takes. But as Chris said, if you clone the repo, there's a folder there, which is called assets. And there's within that folder, there's the samples folder. And you can just drag and drop a WAV file there, and it's available. It becomes available but basically you will be running your own instance of SEMA, okay?
Right.
So it's
Yeah,
cloning that repo and running the SEMA instance in your machine. There are instructions on the README to do that.
Yeah. The instructions are pretty clear. You install Node and then you, Okay, thanks.
Cool.
Yeah, there is another way to make samples. You can kind of generate signals in JavaScript and then throw them to the audio engine, and that's in the tutorials tomorrow. Okay, do we have any more questions? I think on Zoom you can kind of raise your hand in the participants window if you want to ask a question.
So I'll be looking at Slack as well, probably.
Yeah, there's the general discussion.
Oh, is that Alex? Hi. Hi.
Okay. So is there any specific question that we want to choose?
Okay. I think we've got a question here.
Okay.
Well, hello guys. Hello Thor, Francisco, Chris. Congratulations for the tool and the project. Sounds very nice. It's not actually a question, it's a suggestion about the samples. I think since it's kind of hard to add our own samples, I think it would be very useful to have a selection of like 5 or 6 types of kicks and 3 or 4 types of claps to build up some beats. I think it would be very, very useful to like a kick 1, kick 2, kick 3, to have a selection of more sample beats, drums, and I think that would be very useful.
Okay, thanks for that suggestion. Yeah, maybe we could try and find a kind of rhythm pack and bung it into the online version. It should be fine with beat stuff because it's short file sizes. If we chuck a load of samples in that are big, it'll take ages to load. That's the only issue. So if we can find some
like a collection of 808s and 909s.
Yeah. We'll see if we can find a sample pack and add it onto the website. If that's going to be useful to people, that'd be useful to do.
Thank you.
I wonder, Chris, if you could just show the basic kind of maybe screen share of the demo language, just to like talk aloud what is going on with arguments and functions and so on.
Yeah, sure. Let's do that.
Just a little talk aloud, you know, so it's clear to everyone how things work.
Yeah.
And then we can continue, but this might take like 5 minutes or something.
Okay. I'll just share my screen.
There is a question about the mouse Y input.
Okay.
And the mapping. Someone tried to use the ulint to map between 0 and 1. There were some error messages, I think.
Okay. So shall I kind of quickly talk through these tutorials that are up there, then we can look at those questions then. So can you see my screen okay?
Yeah, looks good.
Yeah, great. So we've got videos up for these first tutorials: introduction, inputs and outputs, variables, and sampling. So just really quickly running through these really. This one is just about the kind of general format of this default language, as we've called it. And it really is quite a simple language. There's no classes or templates. There isn't even any looping in it at the moment. It's kind of based around signal flow. And the idea is we have some sort of function and then a bunch of parameters separated by commas. And that's the kind of core thing you need to know about this language, really. So if I want to run a saw wave, if I want to listen to it, I have to put this operator here. We could think of that like a microphone. So you put that next to whatever you want to listen to. And then if I run that, well, we get some sounds. You might notice a bit of delay when you hit evaluate in between things actually running. That's because there's a clock running in the background in the audio engine, and in live coding, we have one block of code running and then we swap it for another block of code and maybe do some kind of little crossfading in between. And that swapping only happens on a new bar. And at the moment, we haven't talked about the clock. That's in tomorrow's tutorials. And you can have some control over when that happens, but that's basically why there's a delay. And that's the kind of fundamentals of how this language works. We can have stuff on multiple lines. I can make a whole bunch of saw waves. They'd all run at once, but I'd only be listening to the one with the output symbol next to it. The next one was about inputs and outputs. So I just kind of talked about that really. Just basically this symbol here. If you want to direct something to a left or right channel, you can put a number in front of it with the number of the channel. So that would be your left channel, that would be your right channel, probably. The variables, so in a programming language, we usually, a variable is where you can store a bit of data. In SEMA, in the audio engine, everything is a signal, which means that a variable in SEMA is a bit like an audio channel. So you can think of it as routing it to a channel on your mixer or through a cable out your sound card. And then when we reuse that variable later, we're basically kind of plugging that channel into something else. Variables in SEMA are always enclosed in 2 colons, and then you can have a name between them. That is the name of your choosing. And then you stick the variable next to the output of a function. So here my sine wave will get stored in this variable here, and then I could go and use that later. I could go and mix it with something else, for example. So that's kind of rough idea of how variables work. But you can put variables anywhere in a statement. So I could, normally in a programming language, but in a kind of typical programming language, a variable always goes on the left-hand side of the statement. In this language, you can put a variable anywhere. So it's like tapping your signal out into an audio channel. So I could put a variable here, for example, and then go and use that later. Then the last tutorial was about playing samples. Yeah, and if you have questions about this, please do put them on Slack and then we can cover them. So we've got this sample library in SEMA. If we go to GitHub, so this is this assets folder that we were just mentioning. If you look in assets and you have a look in samples, there's a whole bunch of samples in here, and which we'll add some drums to. These are out of Thor's Ixylang project. So we reuse that sample library. And basically, samples in SEMA, we work by sending them a trigger. And a trigger is a signal that does a positive zero crossing. That means it used to be below 0 and now it's above 0. And if that happens, then we get a trigger occurring. When a trigger occurs, it can play a sample. And so, for example, I can make triggers with this thing called imp, which means impulse. You might know what an impulse is if you've done a bit of digital audio. So it's basically a 1 in an audio signal. And we can send that to a sample to trigger it. So let's just try a hi-hat here. So in this statement here, I'm making a trigger, which is kind of 1 impulse a second. And I've got this thing here, which is the name of a sample, and it's preceded by a backslash. So you can take the name of anything from this list, drop the .wav off the end, and use its name here with a backslash. And now that should trigger a hi-hat. Except I've got some kind of error. Let's see. If I increase the speed of the impulses, so if I change it to 2, we'll get 2 impulses a second and it'll trigger the sample twice a second. And we could do it once every 2 seconds or something like that. And that's pretty much the basics of how you trigger samples in SEMA. We can also do looping of samples. Maybe just to rewind. So this is a really basic way of sequencing, just doing regular pulses. What we're going to cover tomorrow is doing more complex sequencing and making customized rhythms using this thing called the ratio sequencer. But for now, we'll just keep it basic. And then if you want to do looping, we can use this thing called the sample slicer. So let's just grab an example from here. I've got a sample called Passandrone. And to use the looper or slicer, instead of doing a backslash, I use a bar here instead. So that indicates that we're going to loop the sample. And this takes two parameters. The first one is trigger. And the second is the position in the sample that the sample gets moved to when it receives a trigger. And if I just feed zeros into this, it's just going to loop the sample. If I send it triggers, what this would do is twice a second when I receive an impulse, it will reset the sample position back to 0. So this is a kind of fun tool if you want to make like drum and bass or breakcore or something. It's good for slicing up samples. And we could put a phaser in here to control the position it gets reset to. So you can get some kind of interesting kind of looping and slicing effects with this. Yeah. So that was the first tutorial, 4 tutorial videos which went up for today. And then we'll get into more complicated sequencing tomorrow and a little bit of machine learning. So maybe now is a good time to have a look at some questions.
Yeah, I have taken down some questions that could be interesting to look at. So Tom Betts has a really interesting question and relevant to this first session. It's a question that says, where is the main work intended to happen? Where are we supposed to code? Is it in the live coding window or in the JavaScript window, or does that matter? So I guess that's a question about the playground, really. And maybe we could talk about the playground and how we would work in the playground.
So I guess that depends on the main focus of exploration that you want to experiment. So if you want to try out the live coding language, you'll work on the live coding editor, which is the black one. In the next sessions, we'll see how to work on the machine learning, and we'll use the JavaScript or the model editor, which is the gray one, the white one. And for the last part, we'll be working with the grammar editor, which is the gray editor. So all of these things will be interplaying with each other. But for now, we've just covered mostly the black editor, which is the live coding window with the default language.
So I think you will create your own live coding language in the live coding window. And if you need to extend your live coding with JavaScript, for example, if you're training a machine learning model, or whatever JavaScript you want to write, you can write that in the JavaScript window, and then there is a communication channel between the two windows or the two systems. And that's something we will talk about in the coming days. So I think maybe one thing we could talk a little bit about now is what kind of idea this is. Why do we have a default language? Why do we have a mini language here and not just web audio? And maybe Chris, would you be able to explain how Maximilian is a sound engine written in C and transpiled that to JavaScript? Just very quickly.
Yeah. Absolutely. So what's behind all this is this thing called web audio, which is a kind of maturing now technology, which lets you do music in the browser. 10 years ago, you couldn't do very good music in the browser. You could play sound with Flash or something like that. But now web audio lets us kind of have really tight control and do kind of full customized synthesis. And so we've got this audio engine behind Sema, which kind of runs using browser technologies. But we've also have this library called Maximilian, which is a synthesis and DSP library, which we developed in Goldsmiths at university since about 10 years ago. And this gets used, it's made in C++ and it gets used a lot for teaching, among other things. And what we've done is, through some kind of clever transpiling technology, we've managed to port this library over so we can use it in the background in a web browser. And what that does is it gives us access to lots of stuff that's already been built, so we don't have to remake the wheel in our audio engine, which is kind of nice. So that's sitting in the background, a kind of relatively mature DSP library that we're using here.
So there's an important question here that Max Prikodko, I hope I've pronounced that well. So is there a way to save your code, or should you always keep a copy of it offline? So this is an important question. So basically, when you're editing your code on the playground, Sema is updating this storage, this local storage that exists on your browser, and it's keeping an updated copy. So every time you start the Sema application, every time you go to that link, sema.codes, it will just load, it will read from those variables that exist on your browser. That means that if you want to keep any copies of your work for future use, it's better for you to just copy paste it into an editor or into a document, because otherwise, for now, we don't have any storing mechanism. We're just keeping the live copy throughout sessions, and if you change it, it's going to be updated and changed, though there's no way of saving it. So keep your useful code snippets on an editor, on a document. The save functionality is coming in the near future, but it's not there yet.
There is another very interesting, a bit difficult question here from David Curry. Could you give some examples of how the functionality of the languages we create would differ?
Well, I guess that you can already see that in a few of the different languages that are available, like Rubber Duckling and Nibble are all pretty varied approaches to languages. I think it's a bit tricky to answer that right now, but it might become a lot more evident on Thursday when we start to explore making languages. But also tomorrow we will start to use a different language that's not the default language, so as a part of a machine learning demo. So we'll get a flavor of the kind of different things that can happen.
I think also the point is with this system, we're not trying to create an environment to make everything possible. We're more interested in little languages as being mini languages for a certain purpose. So you might have one language that is a musical piece, or you might have a language that is an instrument, or some specific type of synthesis or machine learning. So you create your own little tool from this system. We're not trying to create a system where you could create your own super collider or your own Czech or something, those languages are perfect and they don't need this. But we're more trying to create the environment to build specific tools for specific purposes, like these scissors here.
And to add to that, you can think of a language as an instrument, and you might want to modify your instrument. So you might not want to make a new language, but just take one that exists and make some little changes to it, which make it more natural for how you express yourself musically.
And of course, there's a philosophical dimension here. You can live code your language as you're live coding. So that's quite nice. It's like working on your toolbox. And not just your tools, because live coding, of course, is about creating some kind of an engine. There was another question about the color coding. Francisco, is there a particular kind of idea behind the color coding?
So is this question on the color coding referring to the syntax highlighting or to the general color coding of the editors?
I think it's the syntax highlighting, yeah.
Syntax highlighting, okay.
Yeah.
Jesse Simpson, right. So basically in the playground and in the different widgets, we have different kinds of notation, and each one of them with their own syntax highlighting. So for instance, on the live coding editor, you have a custom language. You have the default language that we created. And that's using one specific syntax highlighting. If you go to the model editor or to the JavaScript editor, you have JavaScript, and that has JavaScript highlighting, syntax highlighting. If you go to the grammar editor, you have syntax highlighting for nearly files and extended Bacchus-Naur notation. So syntax highlighting here is a way to make all these notations readable and distinct between each other. I have to say that, for instance, the syntax highlighting in the live code editor, it's not fully functional. There are some problems with it because we're applying a generic syntax highlighter. We're not generating custom syntax highlighters as we would probably should for each custom language. So there might be some tiny mistakes there, which you might notice by some misassignment of a color to a number. For instance, you might see a green number where it should be a purple number. But yeah, so that's what we have to say about color coding and syntax highlighting. There is also a set of questions that I think we should address. Some people are talking about the standalone installation and some problems with it. Once you, like Hernani, once you run SEMA local version, does SEMA run totally independently in the computer, or does it still have a connection to certain server? So that's one question. The other one is problems getting the local installation to run on their machines. So in a nutshell, to answer on both these questions, no. Once you clone and run, and once you clone and build and run the local instance of SEM on your machine, the only connection to a server that exists, it's an authentication. But everything else runs local side, client side. So rendering, audio, so the synthesis, the parsing, the compilation, the machine learning, everything is running client side on your browser. Of course, that when we deploy this into a remote server so that everyone has access to it, like sema.codes, you're downloading everything, but still everything is running client-side on your browser. So regarding the questions about the installation of SEMA, you do have to clone the repo into your machine first, and then you do cd into the folder, SEMA folder, and then you do yarn install, and yarn dev, okay?
Thora Francisco, can I just ask, I'm trying to unshare my screen, but Linux on Zoom on Linux doesn't like doing it. I think if one of you as admins could unshare my screen for me.
Okay, I think, oh.
Thanks, good.
Right. So, yeah, so that thing that I was just saying.
I think.
Oh. So first of all, the first thing that you need to do to run the instance is to clone, to get this folder, this zip file with all the code. And then you get instructions on how to install it, which are here. So first you do cd SEMA, then you do npm install or yarn. So these are alternative package managers. Yarn build, yarn dev. So these are the instructions.
I don't think we should necessarily be talking about that now, because it's better to work on the web for this workshop. Use the SEMA that exists on the web. I think most people have been trying out the default language, and it's an interesting language that kind of just hooks up to the audio engine. And you might have seen this. I'm posting a URL in the Zoom chat. I can post it also in the general discussion on Slack. This is a document that has all the kind of ingredients, all the unit generators or functions, whatever we want to call them. And it explains the parameters, the arguments that you put in. So the first argument would be typically the frequency. The next argument might be amplitude or phase or something. Actually, that might be better explained in another document, which is called SEMA Intermediary Language. And that is the document that you need to use when you create your own language. So I'm going to post that as well. In these two windows. So if you look at the document called SEMA Intermediary Language, for example, and you scroll down a little bit, you find, for example, the SAW oscillator, or the sine oscillator, and it tells you what the first argument is and then what the second argument is of these functions. And you see the same with all the math operators and so on. So these are the underlying operators that we use in our default language. And you will be able to use these. These are the ingredients, so to say, of your language. Tokens, right? Can't remember. That you will use when you create your own language. But in a way, I also think they're useful for us to understand what is possible to do in this signal engine, because it's really like a modular synthesizer, so to say, or it's a kind of a set of unit generators that can be hooked up together in any way, and that's what the language will be about, basically. Did you want to add to that, Chris? Or?
Yeah, I guess we'll kind of get to know them as we do more live coding over the week, really.
Yeah, I'm just pointing to them now because I think many of you will be playing around with the default language, and you haven't had the full list of ingredients available yet. So you can find them in these two tutorials. So you might just go in there and grab something and put it in a function in the default language. Like if you're mapping, you could use lin or linear exponential and so on. There are all kinds of filters available as well. And then the clock functions and so on. But that's something Chris is going to talk about tomorrow.
Yeah.
I think we were just going to use an hour for this, and many of you might have other things to do now. I think we should end the session, but we can continue on Slack after this. I guess Chris and Francisco and I will do a little quick meeting now, but we have people working with us on the Slack, and they can maybe contribute or something. There will be more video tutorials uploaded later today.
Yeah, later today.
So those will be available before the session tomorrow, where we will go through further. Do you have any final words, Chris or Francisco?
Yeah, I think if you have questions that you want us to cover in the workshop tomorrow, then we should add a channel on Slack for questions for tomorrow's workshop, I think. So we'll do that. And also, it's great to see some people sharing little code sketches already. And please go ahead and share your work. It's really nice to see what everyone's doing.
Yeah, whatever you find, if you just write 2 lines of code and you think it sounds great or interesting, just post it there, because everyone else can learn from it. And maybe we can do some games of improving each other's code and so on. That's always fun. Forking it. Francisco, did you want to say something?
Just that it was good to have everyone here today, and we're very looking forward to have you tomorrow, and have fun, enjoy SEMA.
Mm-hmm. Yes, so I'll just close the session then and say thank you, everyone. It's great to have all these people here. Some people are not able to join us. It's I think it's 11 o'clock, it's 12 o'clock midnight in Tokyo at the moment. It's really early on the west coast of America, and in New Zealand and Australia, it's the middle of the night. So, but those people are going to be able to join us on the YouTube channels and check the videos and so on, and Slack, of course. So thank you, everyone, for this session, and see you tomorrow, same time, same place, same URL.
Bye-bye. Same SEMA.
Cheers. Bye-bye.
Hey, Ivan, I can see the new normals, huh? What? How can I unmute you? Oh, there. Oh.
Mute?
Hey, there you go.
The new normals.
Good to see you.
It's good
You
to
all right?
see you too. Yes, we are less strict lockdown now here in Barcelona, so it's nice. How are you?
Very good.
I think Thor leave the meeting, but only Thor, no?
Yeah,
so.
I think we're just going to end the meeting now. Okay?
Yeah, that was the idea, no?
Yeah, but okay, I thought everyone would leave the meeting before us, but we're just going to. Okay, now this is the end of the meeting officially. Bye-bye. See you tomorrow. Bye.